Bayesian algorithms helps in generalizing and avoiding overfitting in case of models. Welcome back to my channel. Today we are going to implement the real world scenario or the real world cases of how we are going to implement on Bayesian algorithms, as it has two different methods, lasso and ridge, and we will see on how we can go ahead with that. So let us start. Let us talk about how Bayesian algorithm works with a real world example. Before moving ahead, guys, Bayesian algorithm is there with the combined, regularization techniques. Every time, whenever you are implementing, it will be there with your regularization techniques, because here we are. It is most feasible with the smaller data sets, right? And with smaller data sets, there is a high chance of getting oversimplified data, correct? Because you won't be having much test size and train size, and because that data set is small, samples and your the data is going to be equal every time, and with that it is very difficult for making the generalization properly with machine learning, right? With the machine or the model, and with that it is going to be a difficult job for the predictions to come into its way. And when we are implementing this regularization, it is helpful. It is helpful. Even the number of features are more in case of a smaller data set. We can find the better coefficients for them. And if it's a ridge, we knew that it's going to be a smoother one, because smoother probability curve it is going to give, because it is not making the coefficient 0. However, in case of lasso, it's going to be a peak one, or it's going to create a thicker curve or towards its tail, because here the coefficients are going to be 0. Okay, so we will see both aspects. However, we have the ridge package present in scikit-learn. The lasso package is present in it's not present in scikit-learn, and we will see how the sampling and all these things are happening with case of lasso. Let's explore that, guys. So here I have taken a data set with the Californian district, and how the house prices or the property prices are affected in that area. And let's explore that. Let's explore the data set first. So here the data is saying that we have this different summaries of different house prices, and this is the summary. We have longitude, latitude, then housing median age, that means age of housing complex, then total rooms present in that complex, or what we call that as a society or apartment, right? Then total bedrooms, population, what is the total number of population lived there. Then households, number of households, that means it's a furnished or not furnished, right? In that way. Then the housing value. So here we have median housing value, that is the target value, because we are understanding for the future input, that if we'll go ahead with these inputs for future, how we are going to get the price. Then ocean proximity, what is the distance from the ocean bank, right? So these are your data. Then we have let us explore the head of it. So this is the head, this is how it looks, and all I can see, all are numeric values. And however, we have one categorical variable here, which is ocean proximity. And let's explore the info part. Here we have quite large number of values, guys. So you can see we have large number of values. We have 20,640 rows, and let's see how it behaves. Okay. Then we have drop duplicates. Then we have we can see that we have total bedrooms, which has 207 null values present. Then I'm just seeing the mean and like the descriptive statistics part, I am going ahead and getting it. These are a regular practice, guys, right? Then before moving ahead for the encoding technique on my categorical variable, I want to see how many unique values present in that. So I can see that there are almost 1, 2, 3, 4, 5 unique values present in that. So with that, I am able to see I have 5 unique values. Then after that, what I have to do? I have to go ahead and encode my value or encode my variable. So what I did, I am going here and encoding my variable. Then I am seeing that my ocean proximity is getting converted to my numeric. Then after that, what is the part? I have to fill my null value, right? Feature engineering, right? Or data interpretation. So now I can see that. It's coming false. So this is the way of saying that it is not containing any null values. That after that, what I observed in my data set, that you can see that I have this house median age, then total rooms, total bedrooms, population, then households, right? Then all these 5 or 6 columns are present, which have floating values, or these are floating values. It is not okay for me, because if I'm going ahead and if I'm telling that, like, as a data visualization part, it is not looking good. So I am converting them, because these all are my quantifying data. These are not any data which can be converted into decimals, right? When I'm talking about the age cannot be 41.5. However, when we are saying 41 years and 6 months, then in that case we need to depict in that way, but however we can round it off and we can keep it here. Then we have rooms, total number of rooms cannot be in decimals, right? Then bedrooms again cannot be decimals. Then population cannot be decimals. These are quantifying data, correct? Then households, like the number of items present in per each apartment, or like that, right? So all these are quantifying data. So I am converting them to my int, and once after converted, I am able to see those all are gone. Those decimal values are gone, and we can see the clear data now, right? Now I can go ahead and get my pair plot. When the pair plot is coming, let us explore my heat map. So this is my heat map. Let both of them come. It takes some time, guys. It takes some time for because here the data is huge. Around 20,000 plus data is present, and let's see on how we will get our output at the end, and what will be the coefficients and everything. We will see that. And here, and proceeding further, right, guys, we will explore on how our data behaves with the regression line and everything. However, this is a regression part. We need to cover that. So here you can see during a pair plot what we got, that these are your histograms for single univariate variables, correct? And for univariate variables, that is always a better way on getting the output histograms. However, for bivariate or the dual comparison between two variables, we can go ahead and get this. So this, you can see there are not much outliers present. However, 2-3 places I can see here few are there, here few are there, like that. Now outlier wise, we are good here. It's not so high. Then we can go ahead and understand heat map. So in the heat map, what we are doing, guys, here do we have to filter out any numeric or anything here? No, because here I have, after converting to my all variables to numeric, I am getting my correlation between those variables, and that is always a good practice. Before moving ahead to heat map, you can convert them. Or if you are thinking that those variables or the categorical variables are not going to create any kind of effect, or there will be no better correlation with the target variable, you can go ahead with the numeric part. Then after that you can convert it. But however, whatever steps you are performing, everything is based on your intuition. Everything is based on your research, your R&D, correct? And let's explore the relation part now, because this is the most important step before proceeding. So here I can see that longitude and latitude are negatively correlated. It's not positive even, right? And I can see that the total rooms, total bedrooms, population, household, and the median income, all are getting related to my this values. What is it? Yeah, the house price or the house value, correct? Then we have these total rooms, total bedrooms, population, households are quite correlated among each other, between themselves, right? And the most, if I'll see from this data set, the most affected one with your median house value is your income, because the income is directly proportionate on the effect of your house value. Yeah. Then I can go ahead and draw my box plots. So you can see my box plots are present here, and I can see there are few you will see them as outlier. Do I have to observe them as outliers? So you can see that the value is ending here at 2, but however we have 1 at 3 and 1 at 4. Then here we have this is population, right? So population have few like one value is present at however the values are ending somewhere around 17,000. One value is present at 27,000 and another value is present at 37,000, right? Then here few values are there which are not far, like the highest value is ending around 5,500 and we have few at 6,200 and 300. So sometimes what exactly is happening, right? When we are considering the data, during that time there will be a shift on the median values, because box plot is based on median values, right? And because of that shift, these values will be shown as outliers, but those cannot be outliers, and those do not be treated. Then if we'll go ahead with direct plot for all, like I am going ahead for all with my target variable, because that is the practice, right? We are getting our reg line due to that. And the way we saw during our heat map, this longitude and latitude, this is the longitude. So longitude is negatively correlated with your median value. You can see it's the opposite one. It's not the positive, it's negative. Then we have the latitude. Even latitude is also negative, you can see. Then we have house age. Age is somewhat positive, so you can see the reg line. Then we have, after age, we have total rooms, and what we saw during our heat map, these factors, this total rooms, total bedrooms, and population, everything is well related with the house price. So you can see this is a straight line and good line. Then even bedrooms is giving me the good correlation or the good reg line. Then we have the population, however, is negatively affected, but it's negatively correlated. Then households with your house price, it's giving a better variance and the better reg line. Then you can see the income, right? That's what I was talking about. The income and the median house value, Both are strongly related, and you can see how it is coming, the line. It's completely straight line, and a better, what I can say, it's dividing the area into two. It's in that way, right? So we understood that our income is directly proportionate to your house value or the house price. Now again, I'm going ahead with my head, and before moving ahead, what we understood that we have the ridge regularization present in my scikit-learn. So first we will understand that, and ridge regression or the ridge regularization with Bayesian algorithm is based on the Gaussian prior. Let me take you to the whiteboard and explain you what is Gaussian prior and Laplace prior. So what is my Gaussian prior? So just consider that this is my line, and in Gaussian, what we understood about Gaussian? Gaussian means our normal distribution. So this is my normal distribution, right? And here, this is my mean, correct? Mean. This is my standard deviation. This is my negative standard deviation. This is my negative standard deviation. This is my this is positive, positive, positive. This is negative. So when we are seeing that this whole understanding of our normal distribution curve is based on your mu or the mean and standard deviation. So here, when we're talking about Bayesian algorithm, as we understood that it is following a probability distribution, right, or the distribution function, PDF, probability distribution function, where the data points are considered not a point estimate, however, a distribution. So when we are talking about the points, what exactly we are inferring here? We are inferring about the coefficients, right? Coefficients. And what is the formula for my regression? It's y hat. So this is my y, right? This is my x. This is my x and this is my y. So how it is going to calculate? It is going to calculate for each, right? If you have 10, that means from x1 till x10 it is going to calculate. And what is the formula? Y hat equal to beta 0 plus beta 1 x1. Like that, we should be having till beta 10 x10. So when we are saying the curve, on what that curve is going to come, those curves are going to come on your x1 or the coefficients, right? The various coefficients, beta 1, then beta 2, then beta 3, then beta 4. So when I'm talking about coefficients, the coefficients in case of Gaussian prior is going to make a smooth curve, because here my coefficients are not 0. If it is 0, then everything will fall under here, right? If it is 0, everything will fall under here. And as it is not 0, it's making a smooth curve near this. However, in case of Laplace prior, what exactly is happening? The coefficients are which are not good, or which are not creating much effect, it is going to create a line like this. It's going to create a line like this. So when we are talking about Laplace, you can see this is Laplace. So when we are talking about Laplace prior, here most of my coefficients are 0, because based on the understanding or based on the calculation, the coefficients it is going to make 0, and because of that, it's going to make a steep line here. it's going to make a steep line here. So if you'll see in 3D view, right, this is my 3D view. This is going to be your, this cross section is going to be your Gaussian, and this cross section is going to be your Laplace, right? So this is how my Laplace and Gaussian or the Gaussian prior is going to take a role during our understanding or during our calculation. And this is like whatever I have mentioned, these are your based on your parameters, right? What we understood, what are hyperparameters. Those are the parameters which are taking role during the calculations. So we understood the concept about Gaussian prior. Now let's go ahead and understand on how we are going to implement our Bayesian algorithm or the Bayesian ridge. So first, what we have to do, we have to get our train test bed. Then we have a library or the module which is having which is termed as a Bayesian ridge, and we have metrics, various metrics here, right? Absolute error, the squared error, R2 score, everything, right? So what we understood that here we are applying the basic understanding here is we are applying here regularization technique, because here most of the times here the data size will be lesser, but here we have a huge data set like 20,000 plus. Now what is the next step? I have to get my target variable and my independent variable. So this is my independent variable where I am dropping my median house value, right? Then this is my target variable, correct? Then after that, x train, x test, y train and y test, I'm getting my test size as 20%, and train size split I'm getting at 80%. So I'm going ahead and getting that. Okay, I need to run this. Oh, I need to run this first, then this, then this. Now what is the next step? I have to get my model, and this is my model, initializing the model, right? Bayesian ridge. Then after that, I'm training my model, right? X train, Y train. I'm fitting my model, and these are my parameters. Max iteration 300. What is the meaning of iteration, guys? That means the sampling it is going to create on the trained data, it's 300 times it is going to create sampling. Then alpha 1, alpha 2, lambda 1, lambda 2. So these are the factors, or these are the coefficients, or these are the hyperparameters which it is considering. Alpha init, lambda init, then compute score, fit intercept, copy x true, verbose false. So all these things we are considering, or we are talking this as a pipeline. This is a pipeline of your model. Now we will go ahead and understand two things here. Like what are the things we are understanding? We are going to predict the output now. So while predicting, I want my mean values to be also predicted here. So I want to know what is the mean value for my test data set. So for that, what I have taken? I have taken my mean value, y mean and y standard. So I have taken my mean and standard deviation, and I am getting my prediction for that. Now let's see. This is my shape, x test dot shape. So I have 4128 rows in that, right? Then after that, I am understanding what is my mean value and what is my standard deviation. Let's see that. Predicted values of predicted mean and predicted standard deviation. So this is my mean value, right? And here, if we'll see, guys, 1 minute. If we'll see this is my shape, right? And for each point, whatever the points we have in test data, we will be getting the different values, right? The different values of like how it is behaving, or how better it is with the mean line, right? So if we see that, okay, let me just get the shape of y underscore mean as well. however I dot shape. Let me just see. Yeah. And let's see one more. Y underscore std dot shape. So you can see that for each value, you will be having a, like how it is behaving with the mean line and the standard deviation. You should be able to see that. However, I have taken just five elements or 5 values just to understand how it behaves. So you can see. So here you can see that this is my mean values, or after getting trained. These are my mean values: 75562, 1, then 1669295, then 264, then 275, then 278. So with these values, what exactly is going to happen, guys? It is going to create a curve, right? For its posterior estimation, right? That is the agenda, right? Likelihood, prior, and posterior. So we understood the prior, like we have considered the Gaussian prior, and we are understanding the posterior, and the posterior is going to be a probability distribution, correct? And similarly here the prediction uncertainty, right? This is the uncertainty. These are the indexes, guys, right? These are the indexes, and these are the values. So 1,171, then 1,658, like that we have your the values, and this is how we are going to get our the shape or the curve. So this is your mean, and this is your standard deviation, like that. And however, in case of this, right, or this estimation, what exactly we are understanding, that the whole data points which we have, like 4128, the whole data point will be covered or should be covered inside this range, 99% of my distribution. That should be the inference. And now we can evaluate the model. So we understood the mean and standard deviation, which is the goal to get here, because we should understand how it behaves. So we have got our mean absolute error, mean squared error, root mean square error, and R square, and we are getting our coefficients. Y predicted is not. Okay. I need to get my predicted value, which is my mean here. Now let's see how we are getting the output. So you can see that mean absolute error is coming 1844, mean squared error this, root mean square this, then R2 score we are getting 61%. That means the model is 61% accurate in this case. Then these are the model parameters. So let's change that to standard deviation. Standard deviation we should not consider here, because that is nothing but your the error, right? The error part of the variance part, how it is present, correct? But still, if we want to check on how it comes with the standard deviation, so we know with mean we are getting, so with standard deviation we are getting very high values here, right? High values. However, if you want to see what is the exact mean, like what is the exact mean and standard deviation, it is present. So this is the value. This is the median house value, right? So for median house value, we have the mean value, or the correct mean value is 2,06,855 or 2,06,856 if we'll round it off. Then standard we are getting 1,15,396. However, what we are getting, let's see that. We are getting the result, or the mean absolute error is 1,13,703, right? And root mean square error also we are getting more. So it is always a better practice to take your mean here, not the standard deviation. The standard deviation is your variance. Y underscore mean Y underscore mean. Okay. So we got this, and we at the same time we are getting our intercept values. So this is your intercept. That means this is your beta 0, right? Then your total coefficients. This is your longitude. It's coming -427223104. Latitude, we are getting -42487, right? Housing median age, we are getting in the positive term. Then total rooms, we are getting in negative. Total bedrooms, we are getting positive. Population, we are getting in negative. Households, we are getting this. Then median income, we are getting 40,516, and ocean proximity, we are getting 300 -308. So these are the coefficients for or the final coefficients which we got for after after your Bayesian ridge calculation or the estimation. And you can see that it has not made any of these coefficients 0. However, it has reduced it. You can see total rooms is very less. Then population is very less and households is less as compared to the other coefficients. Then we have we can plot it. What is the actual house value and what is the predicted house value, and let's see how we are getting. So here y predicted is nothing but y mean. Okay, let me do one thing. Let me create another prediction. Like this is your mean, right? Now let me take another row and let me get my y predicted here. Predict the test data. So here I can just take y underscore predict and let's see how we are getting the output. It just should be just x test. Now if I'll give input to this, let's see what we are getting. This is y mean, y standard deviation. You don't have to worry. We will just take this y predicted, and let's see how we are getting our output. So yeah, see, you can see it's totally equal to your y mean value, right? You can see it 51,844 and all. However, here, right, in case of this, we are not getting any line, or the line is very low here. You can see it's just one dot I'm getting, right? And if I just take this 100, because the data point is huge, that's why. Okay, just take 10,000. Yeah, so you can see the data here. It's showing in this direction only, right? So 0 to 10,000. Okay, let me just take value till 2 lakh. Okay. So you can see that my values are getting in this format, and you can see that I have taken the values till 2 lakhs, whichever values we have till 2 lakhs it is going to take, and you can see that this is my actual house price and this is my predicted house price. And if we take till 6 lakhs, then okay, let's see, do we have any value till 6 lakhs? Okay, we do have values or the predictions till 6 lakhs. So you can see it's crossing, right? It's crossing and it is giving a beautiful result out of it. And you can see that the values which are closer to this, those should be your predicted value. The values or the blue dots which are closer to this line are going to be your predicted values. And this is how we can achieve our goal or the final predictions with prior Bayesian ridge. And what we understood out of it, the model estimates the mean prediction and the uncertainty for each prediction. For each prediction, we understood that how we can calculate mean and standard deviation using this, because here the whole concept is on probability distribution. Then we understood our metrics, right? Then we understood how we can apply the L2 regularization through your Gaussian primes, right? And we understood everything. Now, I do not want to explain much about this lasso because lasso, what exactly is happening, right? When we are sampling, when we are doing sampling, it is taking a huge GPU memory and it is completely, staying hung for the long time. So I will share this. Then try this in Google Colab and guys, if you do not have any system, then you don't have to worry. Just understand the concepts by going through the video. If you are not understanding in once, then go ahead and through this video multiple times and just understand that, so that it will be helpful for your interview. Now, let's see. The same thing I have taken, the same California housing module I have taken. However, I should be taking a lesser amount of data here. You can try out the data sets which I provided, the regression data sets which I provided already. You can take that and you can try this out. However, I have taken with the larger data sets. That's why it is taking more time for sampling and it's stuck. So, you can see that I have taken my libraries in case of Bayesian lasso. Then I'm reading my CSV. Then this is my head, right? Now I'm coming down directly to my concept. So your lasso is present in PYMC. What is PYMC? That's pi tensor, guys. That's pi tensor, and it is helpful. This PYMC is helpful for specific to Bayesian, understanding Bayesian statistical methods and probabilistic methods. And the next thing is what, guys? We have to get our train test split, then standard scalar here. Then if you do not have, so the first time if you run this, you will get error because this library might not be there in your system or in your environment. So what you can do, just you need to use let me write it here, pip install PYMC in your prompt, and that will be installed and you won't be getting any error messages after that. So the first timer you will get error. You don't have to worry about it. You just need to use this command. Then after that, what we can do, I'm going ahead and am I getting my X and Y or the median values. Okay, I'm just not running anything here because it's going to be cumbersome. Clear all cell output. Let me clear all. Okay, now what is the next step? I am going ahead with my first what we are doing here, guys. We are going ahead with the Laplace prior here, correct? So for that, what we are doing, we are focusing on each feature every time. So we will do this exercise for each feature every time for better understanding. So what we are doing, we are taking the total rooms because we saw the total rooms is having better effect, right? So we have taken the total rooms. Then after that we are applying scalar and we are transforming that with standard scalar. Then after that I have taken my that xscale dot that particular feature and I'm going ahead. So with that, what we can understand, we can understand the relationship between total rooms and my total price. Then here is the main thing which you have to understand. So here this is my Bayesian lasso model, and with that what we are understanding, we are getting my model, right? We are getting my model, and how we are getting my model? With pm dot model. So this is my pm. We have already taken import pymcs pm. So inside that is the same thing. We are initializing our model, right? So the same thing, we are getting model parameter and we are giving it a LIS. So here I am telling BL underscore model, that means my lasso model. What are the inputs we have to take here? We have to calculate W, B and sigma. So what is W here, guys? So we have to use Laplace. For W, we have to get Laplace. For B, we have to get normal. So what is Laplace here, guys? We have to take W, then mu equal to 0, B equal to 1. So what is the meaning of this? It's a slope in regression, and why Laplace? It's due to the L1. And here mu should be mean and B should be standard deviation, right? So this is how we, or this is the coefficients or the slope, I can say, or the gradient in case of your regression, right? Then B. What is B? B means your what? Weight. So that B should be following your normal. So here I have taken my normal. I am going ahead with mu and sigma. So here sigma is what, guys? Sigma is a noise or error, correct? And sigma, again, how we are calculating? We are calculating with pm dot half Cauchy. Half Cauchy is what, guys? It's a distribution. It's a distribution. And why we're telling half Cauchy? Half Cauchy is going to give your output towards your positiveness, right? And these all are parameters, guys, and these all are predefined. So we have to follow these syntaxes. Then we should be able to get our output. Then what we are doing, guys? We are training we are getting our mu equal to W into X plus B. This is what we are getting, correct? Mu equal to W plus X in X plus B. What is that? Mu means it's our output here, right? Then Y observation we can take, and inside that Y observation we are taking normal again. So this is again similar to this Y towards normal, mu, sigma, likelihood function. This is a likelihood function. So here we are calculating each function. We are calculating prior, we are calculating likelihood, we are calculating posterior. Then we are taking trace. In trace, I am taking the sample size of 2000. Then tune is 1000. Then target acceptance 0.9. So all the samples drawn from the posterior distribution of the model parameters. So these are all your parameters, guys. You just need to do R&D on this. How we can get it. Then this is your predictive samples. Okay. Now we understood the likelihood and we understood the prior. Now we can get my posterior part. So how we are getting posterior part? We are taking the X sequence. We are taking the X train, then mean and max and 100. Then we are taking the model. Then we are predicting our posterior. How we are predicting? We have sample posterior predictive method. Just the way we are predicting, right? We have predict, right? Similarly, we have sample posterior predictor. So here, what exactly is happening? It is we are taking the trace or the sample which we have drawn. Then var names, what are the variables on which it's going to be calculated? We have W, B and sigma. Then prediction should be true. So once we calculate, we will get our output. And here one more important fact, guys. Here the whole sampling method is happening based on the Markov chain and draw. Markov chain and draw, MCMC sampler. And what is the sampling, guys? Let me take you to the whiteboard and explain you. What is sampling? Sampling is, so suppose here they have taken 2000, right? 2000 sample size. So first what they will take, they will just take some random sample of 10, or maybe that 10 will increase to 100. Then it is going to increase to 200. So it is going to be pass, guys. Like in first pass, they will give 10. Then in second pass, it is going to increase to 20 or like 30. Like that, they will keep a constant value and they will do it, right? So in this case, what exactly is happening? They have taken, you can see, the sampling, this is the sampling method, and in that sampling, they have taken 2000 at first. Then tune means what exactly it is, guys? So here tune means what exactly it is, guys? It is your number of iterations. So that 2000, input 2000 quantity of sample, it's going to iterate over 1000 times. Through each time, they will take random sample, and the acceptance criteria should be 90% of those samples. And the random seed, that's nothing but what exactly it is. It's nothing but your fixed amount of data, right? Which when we're talking about seeding, we understood in random sampling, correct? So during that time, they will take like the first time, whatever the amount they will take, they will consider the same amount of data. However, they will shuffle those data every time during their consideration or during their sampling. So we understood everything. Now, what is the next step? We will get our mean and intercept, correct? The same thing we got it in our ridge model, correct? So here we are getting our mean. So this is how we are getting our mean. This is the method, or this the code for that. Trace posterior W mean dot mean chain draw values. Then posterior intercept, right? We are getting our intercept. Intercept, this is your intercept, right? This is your angle, correct? Then we are getting the same thing. Then we are getting our predicted mean. That is nothing but a posterior mean into x sequence plus posterior intercept. That's nothing but a formula, right, guys? Then what we have to get our confidence interval. So this is my confidence interval formula. This is how we are getting this. A predicted sample. We are taking the predicted samples 2.5% lower and 97.5% higher, or like these are the labels. Whatever the output we are getting, the predicted output, we are taking the low 2.5 and a high 97.5, and that range should be between that of the confidence interval. That's what we are considering. Then finally we are visualizing on the relation between total room and median house value. So this is the whole code. Just observe this, understand this, how we are calculating this, and we will meet during our next video. That is all for now, guys. We will talk about cross validation during our next video. And if you really like the content, if my content is helpful in solving your real world problems, then please go ahead and subscribe. Don't miss to hit the bell icon during subscribing. Like, share your comments, share your feedback, share this channel link to all your friends and near ones. Till the next time, see you. Bye. Take care.